Okay. So yeah, so nothing in Rhino other than this volume. Everything else is going to be done inside of Grasshopper. So I'm going to open Grasshopper, and this is the script that I have given you. I'll try to clean it up a little bit more and label everything, so that way you understand what each thing is doing. But the idea is that you bring in this and you maybe change some sliders here and there and get some studies. So in order, so there's 3 plugins for this, just so everybody knows. The plugin, the Ladybug Radiant stuff is what does all these tools, and I do have another plugin here called Bifocals, which gives you the names of all of the nodes, so you can see what each node is named. That's just helpful for teaching, so you guys can see what it says. And I also find it helpful when you're building scripts. So all you need to do to bring in the geometry, I'm going to actually clear the values here, is in Rhino, select on the thing you build. Ideally, it's just a solid volume, like a box. You can model some sort of floor plan and extrude it, but ideally it's a solid volume with the top, kind of 6-sided square or multi-sided, but having kind of like verticals for your walls, a top for your roof, and a bottom for your floor. Because the tool that we're going to use in Honeybee is going to create what we call a room from a solid. So it's going to take a solid and it's going to make a lot of guesses. It's going to say, oh, if it's a horizontal surface and it's on top of everything, then it must be a roof. If it's on the bottom, it must be a floor. If it's vertical, then it must be a wall. So this is like the easiest way to create a room. Honeybee allows you to kind of like do things very simply, but then there's also insane amount of detail you can add into it. We're trying to be as simple as possible. So all you need to do to bring in your geometry is inside of Rhino, click on your geometry. You'll see this geometry node here. It says add your volume. I click on this node, I right click, I set one geometry, and now I'm no longer orange, which means that this is pulling in this volume here. Inside of Rhino, I'm just going to hide that so we can see what is being represented. So this is just what's being represented in Grasshopper as my room. You see that there should be a north, south, east, west, and it'll immediately place apertures. These are windows right now. So these, and I'll show you how they're being generated, but nothing is modeled. This is just being generated by the script. So once that's in, you should have, and we could run this right now and get a result. But I'll show you, kind of walk you through all the pieces of it and how it works and why it works. So that way you can at least hopefully understand it. So first things first, we have our volume, and now we may want to add windows to it, right? So again, you could model each wall separately, each window separately, each door, all that stuff. You could model all those things as planes and bring them in piece by piece. But we're trying to get quick results and kind of understand, like, I put windows here, if they're this tall, if they're this wide, if they're this, that, or the other, this is how the sun is changing inside my space quickly. So I'm using what is called the apertures by ratio tool in Honeybee, which basically says, it gives a percentage. And it says, I want a certain percentage of this facade to be a window or an aperture, right? So right now, I'm running them through this, which is a facade thing, so I could change each facade separately. So we'll turn this all the way down. So you'll see that the only facade that has any windows on it is this guy right here, which is represented by what is called the south facade. Just note that you can see this compass. That's not actually the south facade. It's just calling that the south. I could orient this building so that it becomes the south, but just try to remember that these are not actually cardinal directions. They're just, a label that Honeybee has put on that surface. So you can see here I have these windows, and they are at 6%. So that means it's 6% of this facade is aperture. If I increase this slider, they get wider, and eventually they merge together, and they become one big window. I can go all the way up to I think 95 is the highest you can go. Any more, you'll get an error. So you can start to set the different, you could just kind of increase the facade, increase how much aperture is on that facade. And over here, you'll see that there's a lot of things you can plug in. I actually don't need these two. I could work without them, but they're helpful for what you all are doing. So I can change. What do we think these two guys are doing right here? So these two sliders are being plugged into those two spots. What do you think they're doing along with the windows? Any thoughts? These two sliders here.
Change the height.
Height. Changing the height. Yes. You were gonna say? So sill height and window height, right? What's the difference between those two?
Sill height is like how far it is off the ground.
So sill height is where that bottom line is. So sill height, this is the sill height. Right here, this is this window sill. And the window height is where the top of the window is, right? So if I change these, if I address these, you can see the windows just move up and down, but they stay the same height. You can move them this way, they get smaller and they get squatter as I kind of change that. So this is helpful. You may want to adjust your windows up and down or change their dimension in the facade that you built, right? So if I want to add more windows on different facades, I can come up here and increase this guy. So you can see there's windows being added over there. I can increase this guy. I got windows over there. So I can kind of play with all the different facades. I can not have any windows. I can do, it's just a percentage. It's going to equally space them apart and adjust them based on that percentage. You can change their horizontal separation, vertical separation, make them operable, those kind of things if you want to. All of these nodes over here just take a number, So what kind of horizontal separation do you want? If I wanted to, I could just plug these into here, and you'll see that I can increase or decrease their horizontal separation as well. I'm just going to unplug that like that. So I'm going to leave I'm only going to put windows on the west and the south for now. Does everybody understand basically what's happening with those two nodes? Because all this tool is saying is it's taking your north, south, east, west, it's taking our location on the planet, and it's saying, okay, if this was a hole in the wall and there was glass there, how many rays of sun are going to go through this hole into this space and hit that floor, right? It's really all we're doing. It's very simple in some senses and complicated in others. So I'll get to the shades later. We're just going to run through the windows first. So just so you know how this operates and how Honeybee works, maybe you remember this from the last time you looked at it, is you need to imagine that it's going to test spots on the floor. So if the room we were modeling was this one, and we had these walls built and these windows, imagine putting like sensor grids at every single one of these spots at the carpet, every single spot. And at this spot, at a certain hour of the year, we're going to report how much sun comes through and touches that spot, this spot, that spot, so on and so forth. So you have to create what's called a sensor grid. You don't necessarily need to create it. It's already in here. I'm just showing you where it is. It's up here. If you wanted to have a more dense grid, you could change the grid size, which is this guy right here. We can add less or more. The more grids you add, the longer it's going to take to run the calculations. So just remember that. And then you can also set its height off the ground, because you may not want to test. So imagine in this room, like what surface in this room would we want to test for sunlight? Do you think would be a better surface than just the floor? The desks, right? So you might say, I want to know how much light is hitting at this level above the ground rather than on the ground. Because if it's on the ground, it's not that useful to me. But if it's on this desk, that's a better tool. So you can change the height of that grid, so it knows where you're testing. So you can see that they're elevated Right now, 2 feet. Put them 3 feet off the ground is where the grid is. I'm just going to hide this again so we don't have to see it. Lots of fancy stuff happens in Honeybee. You build rooms, you add rooms to a model, and then you assign the grids to the model, and then that's how you run the test. So you don't necessarily need to worry about these nodes here, but that is what's happening. We're basically pulling all the faces together, all the apertures together. Eventually, if we have shades, we'll add them. And we're saying, okay, this model is related to this grid, and now we're going to run the analysis. So that's literally all that you would have to change to get started. So you can change the apertures. Well, there's two other things. There's one other thing we might want to change that I'll show you here in a second, and we'll get to shades afterwards. But right now, we can start running analysis on this tiny little box for, as you can see down here, is the weather data. The Philadelphia regions for Philadelphia Airport. You don't need to change anything here, but that's where it's pulling it from. And you can see our orientation of the building here. So the other thing that we may want to add, let me add a note here so I don't forget. Is the north arrow. It's a thing called Scribble. And you can add notes. Put this down here a little. So adjusting north. So this compass here is just generated by this node here. It's not actually plugged into anything. This is just a degree value, which tells you how far. Right now it's at 90, so it's in that direction. If I rotate it, you'll see that north rotates wherever, I can rotate it all the way wherever I want. So for now, I'm going to leave it at 90. I would suggest turn off the sound. Or turn down the sound. I would suggest running this model in a manner in which you could imagine what the results would be first before you adjust north exactly right and put your apertures in. I would say test this with something that you can expect, which is why I am only putting windows on the south and west facades. Because what would I imagine? What would you all imagine to happen if I started testing how much sun was hitting the floor in that room? What would, if I looked at a plan of this, and this is my south facade, where would you imagine there to be more or less sun? Any ideas? More sun on the south side. So we should expect to see more sun over here and less sun deeper into the space. So I'm just saying I like to run a test, because if it comes out different than that, if all of a sudden I'm seeing more sun on the opposite side, something's wrong. I need to address it. So I like to run things in a way that I can predict it first, and then I kind of adjust it to where I expect a different result. So there are 3 different analyses that you can run that I have set up here. I forgot to label one of them. So the 3 of them are the direct sun hours, annual daylight analysis, and this one is a glare analysis. What do we think direct sun hours is? Was that?
Hours that the building is getting hit directly by the sun.
The building?
The sun is shining.
I mean, you're close, but it's not the building, it's the sensor. So it's the interior space. So how much sun is hitting the interior space? In Honeybee, if you hover over any node, they actually have really good descriptions about what's happening. So you can see here it says calculate the number of hours of direct sun received by the grid sensors in a Honeybee model. The so it's just telling you how it runs. But it's basically saying over every hour of the year, it's going to look at every single hour of the year and say, at this grid point, is there direct sunlight on it? No? All right, then that's 0. Is there direct sunlight on that one? Yes. 1. And it'll just mark every single hour that each grid gets hit, and it'll show it in a graphical way. So this, all of our information is kind of being plugged in. Our model's coming in. Our weather data is coming in. The north arrow is coming in. In order to run all of these, you have to change these toggles to say true. In general, just for your own sanity, keep them false until you're ready to run them, because every change that you make, if you keep it true and you make a change, as I'll probably do here while we play with them, every time you change it, it runs again, and it's going to take 30 seconds to figure it out. This guy over here is just a graphical tool to show the information on the model in a graphical way. So I'm going to click true, and I double clicked, and now a black box should pop up. And if we're lucky, it'll run like this. So it's literally running through every single hour of the day, every single day of the year, and it's figuring out, is there direct sun in these spots or not. As long as you don't have too many grid points, it should only take 10 to 15 seconds to run. So now, if I go back over here in my model and I look at my top view, I get this. What do we think this means?
The intensity of light on this side.
So not on the facade. Keeper. It's not on the facade. It's literally on the there are tools that you can get like intensity of light on the facade. This is how much light is actually hitting 3 feet off the ground in the room. But it's not intensity. So it's not like at this point in day it's this many lumens or lux. It is literally, is there a direct path from this point to the sun at every hour of the year, right? So not intensity, literally, is there sun on this spot, and how many hours is there sun on this spot? So what do we think these numbers mean? Any guesses? Hours of the year. So you can see down here is 50, up here is 1,654. So the darkest red spots, those guys right there, those dark red spots are getting at least 1,654 hours of sun in a year. These guys back here, probably this back corner, is getting 50 or less. So you can see, obviously, we're not getting much sun penetration into the space, which is what we would probably expect from a model that has no windows on the east facade, no windows on the north facade, and relatively small windows on the south facade. Granted, they're tall, so it's probably why we're getting some penetration. So if you wanted to run it again and say, oh, I want to change these windows, I want to adjust these, my south windows, what I would suggest you do is set it to false for a second, so that way it doesn't run every time you change something. You come back over here, and you can make a really big window. Let's make it one big glass window. Imagine it's a big glass curtain wall on that facade. So 65% of it is window. I can run it again. What's that? What's that?
I was just remarking about how 65% of the wall is window.
Well, you figure skyscrapers are 100% window. Well, when we talk about details in storefront, all of you are going to have storefront, curtain wall, something in your building. I want to make you draw it endlessly by the end of the semester, so you'll have a pretty good understanding. So now you can see this result. A lot different than the other one. So now I have a really strong bead of sun. If I go back to my top view. But you can also see it was 1,600 hours before. Now we're 3,000 hours. So that red represents 3,000 hours of sunlight. It's penetrating a lot deeper into space. You were getting 1,600 just at the line of the facade. Now we're getting 1,600 hours, a couple feet into the building. We still don't have any sun back here, but you could imagine we don't have that because the building's deep, the windows are only so big. We would need taller windows and all that kind of stuff. Yes?
So I'm running it on a geometry that I made, and it's looking like it's incorrect based on the compass trajectory.
Does look incorrect. Okay. Can you, I see, I'm not seeing any of your, yes, the grid, you turn on this guy here. This is, this. 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 all one. Okay, there we go.
Yeah, it's the same.
Okay, and then where's our apertures? Can you turn that back on? Behind them. Over here.
Should be.
And so you look, zoom in. Okay, so can we see them on the sun anywhere? No. When it pops up, you can exit out of it. This is also a little bit more complex in the shape, so I'm curious how it would interpret this. I'm just not seeing any windows anywhere. Can you hide your any is all the geometry hidden inside of Rhino right now? Can you hide that? And then
Let's see. Let's see.
did you okay, you go, and everything? Your mouse is too fast. Alright, so your windows are there, there, there. South this side. Which one did you run? Oh, that's a different analysis.
Oh.
So see if this one pops up. How you might imagine. I double clicked it. See if that doesn't work, then we'll take a look again. So just so everyone knows, I was running this middle analysis, which is direct sun hours. These other ones will show differently. So we'll talk about them in a second. Does everybody understand the basic premise? Look more like it should. Basic premise of how what this is showing us, how it might be valuable, and how we can maybe use it to help understand how the sun is operating in the environment. Okay, so that's just direct sun hours. That doesn't really tell us much about what kind of light. As Ari suggested, a few minutes ago, he said the intensity of the light, right? So that's not really what this is showing us. This is just showing us, is sun hitting the spot at a specific time? But what does show us intensity is this analysis up here, which is called the annual daylight analysis. So this one, what this does is you can set, or you can just leave the default settings, thresholds of light. So what's the intensity of light that you want to measure? So what is that intensity? Does anybody know the different measurements of light and what intensity I think is technically intensity would be classified as measurement of light? What's that? Lumens is not. I think lumens is brightness, I believe. Intensity is a little different. My understanding. I don't actually fully understand the difference between them. This is not measuring lumens. Lumens is like a light bulb has X lumens, so it's a certain brightness. Intensity is about how many rays are passing through a spot of like a space in a moment, and that's called lux. So this is setting thresholds of lux. If you hover over, like I said, if you hover over anything in Grasshopper, it'll tell you what it's measuring. So here it's saying that it's measuring different thresholds of lux. There's a low end, a kind of like a goal end, and then an upper level. So the low end on the default is 300, the low end is 100 lux. The high end is 3,000. but the goal is 300, right? So that's what this default is showing. And it's going to measure, if I hover over this, it'll say that there are few outputs that come out of this one. The other one down here only has one output, hours. This one has multiple. This has daylight autonomy, continuous daylight autonomy, useful daylight illuminance low, useful daylight illuminance upper, or lower and upper. So what this is saying is, at each one of the sensor points, what percent of the year is that spot in the zone that I want it to be in? Does that kind of make sense? So it's saying, at this spot right here, what percentage of hours of the year is this spot in a good level of light versus too high, too low? Is it too much light here? Is it not enough light here? Is it the right little bit of Goldilocks? You know, too little, too hot, too cold, just right, right? So this is measuring something different, and this is percentage. So you can see here, I'm going to turn off this guy because we don't want two things on top of each other. And I'm going to run this guy as is. Same inputs, model, weather data, and the north arrow. It's going to run. It's going to give us a slightly... So right now, actually, I didn't realize what... So right now I have plugged in the low. So what do we think this is useful daylight lower. So what this is actually going to show me is what percentage of the year am I below the threshold in spots. So when is it, how much, at every spot in this room, what percentage of the year is it below the level of light that I want it to be? So this is going to look opposite, and this is why yours looked opposite. So this is the opposite of what we would imagine. We see red over here and blue over here. Why do we see red here and blue here? And these, like, the number is 3 all the way down to 0. Any ideas? Everyone's head down.
It's below 0's like the bar where it's 0. And then 363 is the amount of hours below.
So it's not hours, this is percentage. So good guess.
Percentage below what it should be.
Yes. So this spot at the worst spots back here, 3%. Make sure that I'm imagining the percentage right. This is off the percentage of time. So 3% of the time, these are below the threshold. They're underneath like the lowest level of light that we want. On the opposite end, the blue ends are never. And so keep in mind, this does not count nighttime. This is only counting daytime light. It's not counting like night when there's no sunlight coming in here. So it's filtering out all of the nighttime results. It's actually, if we're being truly honest, it's actually running on a schedule of when this building is occupied. That's a whole different thing. We won't worry about that right now. We'll worry about that later this semester. So what it's really saying is this building is occupied from this hour to this hour every single day, or Monday through Friday, or whatever. So it's only counting those hours. But so this area here, 0% of the time is below the threshold during the day in the scheduled time, and 3% of the time this is below. So if I do the opposite, I should see down here I have the upper version. I can bring that in and it sees the opposite. So 88.97% of the time, this is above the threshold, right? So what would we deduce from that? Like this space right here. It's hot. It definitely would be hot in the summer. It definitely would feel heat because I have no shade whatsoever. Yes, this area is probably too bright a lot of the time. And maybe we should address that in some manner with shading or something like that. You want to put these big windows on maybe our south facade, but you can start to see like, oh, I'm going to get people sit. If I was a desk person working and I was sitting here during the day, might be a little during the summer, it might be a little uncomfortable. And then these other results are similar. These are kind of daylight autonomy is like not just below and above the threshold. It's like, is it within the lower and upper? So 99.8% of the time, it is either above or within these spots here. So, but this isn't necessarily a good result. It means that it's probably too hot in those spaces. I'll send you all a article. It talks about daylight autonomy. It's actually a relatively recent daylighting evaluation tool, like in the either late 90s or early 2000s, that this was kind of like started to be developed. But it does have some useful uses, I guess. Cool. So the last one I'll show you, and then we'll go into shading and whatnot, is, I'm going to change this to false, is glare. This is, what do we think this is measuring? Has anybody worked in an office? Who's here worked in an office space before? Doesn't have to be architecture. Was there big windows anywhere? Did you anything like that in those offices, or was it all small, not that big of a deal? Huge windows. Did they face, or certain times of the day, was it unbearable to sit near them?
No. It did get pretty hot sometimes, but
Mm.
no glare.
No glare?
And the window was like the window and then the desk was.
What do you know? What direction the window faced? Was there ever direct sunlight coming through it?
If I had to guess, I think it faced east.
Okay. So you would get direct sunlight in the morning, maybe, if you were there early enough. So the point of glare, when I had my first architecture job, maybe because I was the new guy, they sat me at a desk that faced a curtain wall. So like imagine a 30-foot high window, like 50 feet wide. My desk was here, and on the other side of my computer was glass. I looked right outside. Between like noon and like 3 o'clock, I could literally not see my computer screen. I had to wear sunglasses at my desk to see my computer screen because the glare was that bad. So when there's heavy light coming through a window, it can be very distracting or even unbearable. And this node attempts to show you what percentage of time in certain spaces is the glare unbearable. So if I hit true on that and let it run, because I feel like you're all going to go to the Heliodon and you're going to put windows on your building, and then you're going to realize like, oh, I'm not getting a lot of light deep in my building, so I'm going to make bigger windows, wider, this, that, and the other. But there are downsides to those things. You can have windows that face south. Think of a skyscraper that have no shades on them that do not produce glare. Does anybody know why? Not necessarily special glass, but yes, different kind of glass. A tinted glass will prevent glare from coming off those windows. So here's the result. Let me just remember what the result.
I hit toggle to true and it turned red.
Estimate glare at each sensor. So look at that in a second. So this is calculating the percent of time that the area in question is free of glare. So if it's red, then it has the least amount of glare. If it's blue, it has the most amount of glare. So you can see all of this place. So if this was an office space, what's the inverse of 14%? What's 76%? 76% of the time in this spot of the building, you're going to have unbearable glare through the light, and you will be sitting at your desk squinting because you're going to be blasted with light from that side. If you're way back here, you probably have no light, so you're dark, but you never have any glare. So I guess that's the only benefit of sitting back in the corner. So if you don't know like I said, these are all percentages. The other one was hours. If you don't know what you're looking at, if you read this, it'll say here, the resulting DGP, which is what we're measuring, is used to compute glare autonomy, which is the percentage of occupied time that a view is free of glare. So the percentage is the time that you're free of glare. These are useful tools when having big glass facades. Yes, sir.
I toggled it true that the command turned red.
Well, that means there's a bad error.
Yeah.
It's not working.
But I didn't change it.
What's that?
I didn't change it.
You hover over the little red bubble there. Oh, Windows annual glare is not installed, so you may need to reinstall Radiance again. Because maybe this is a new node that isn't in the one you had. Radiance is, if you look at the email I sent, there's an email from Martin that takes you to that, which is how you install a Radiance, the newest Radiance plugin. If you see a red, if like you're running these and you see orange, if you see orange in Grasshopper, that means there's some error, something being plugged in is just not being calculated properly. If you see red, that means there's like a critical error, it's unrunnable, and little bubbles will pop up, a red bubble or an orange bubble. If you hover over that, it'll tell you what the actual error is. Zach, I don't think, had the latest and greatest.
Like 8 files.
There's an exe file.
EXE.
Yeah, Windows. Okay. Cool. Too cool for school. All right. So now you could play with these things. Let me go back to, you change this to, any questions about any of these? What they show and why they're valuable. Nothing? Cute. So, we ran it all with like, total north, south, east, west cardinal directions. If we wanted to rotate those, remember this is how we can rotate the north, south, east, and west. So we can, if I rotate it that way and I run one of these again, I should see different results because now my south facade is no longer, the facade that has the biggest amount of windows is no longer facing directly south. The other way you can do that is leave north, south, east, west in the exact same direction. You could rotate your model, but it's probably easier to just rotate north, south, east, west. Hypercritical, you do that. So you can see now, I just ran it again. This is the total hours, and you can see that I get a different result with most of my hours of sun kind of in that bottom corner because, as you imagine, that's facing south. So I'm going to flip this back to thing. I'm going to show you how to add shades because that is one method you might use to adjust this. So similarly, similar to creating the windows, I'm going to turn these windows down a little bit. We can create shades without having to model anything. So down here is all of the shade commands. And you can see they have the same facade. So if you want to add shades for each facade, different shades for each facade, you can have multiple versions of this. So if we wanted to add shades to our south facade here, which is actually labeled as east, so just remember that's east. I can add them here by plugging in a maybe. Oh, it's not east. It's not working. Broke it. What did I do? Oh. I need a number as well. So there. So with a number, so there's two plugins for this. So this is, you can change the depth of your shade, or you can change the count. So you can see that they added some horizontal shades there at the top of the window. I can change the depth of that shade by increasing it. I can add like more of a louver type system by increasing the amount that direction. So you can start to see how if I have a really deep shade, one really deep shade like this, and rerunning some of these, how that might affect the sun on this building. So I just run this again. So the point of this being that you're going to build a model for the Heliodon, which is going to take you, a little bit of time. Then you're going to go to the Heliodon, test it. You're going to have one studio session to do that. You're going to come back. You're going to make some guesses and change your model again. Go back and try it one more time. In a perfect world, you would do that continuously. So I don't know if you remember what the result was. But there was a lot of sun down here. There's a lot more sun in this area, but with the shade, I've decreased that a lot. So then I could test multiple versions of this and see what the glare is like, what the, am I getting the right amount of light in those spaces? So, this is just a quick way that you can just toggle some of these. If I wanted to add one more shade, I'm just gonna pull this up like that. It's gonna run again. So this is going to add potentially two shades, one at the top, one in the middle of the window. We should probably drastically reduce the amount of hours that hits that edge. And then change it that drastically, but it did change it. Actually, it did change it pretty drastically. So the key thing to remember is this scale, the color scale, stays the same, but the numbers change. So before it was 3,000, now it's 1,700. So I halved the amount of hours that light hits those spots. Yeah. So then you could also do. So this is a south facade. So we did horizontal ones. If I wanted to adjust the west one, as we discussed earlier, we would do vertical ones. And the west facade is the south, actually. So to do verticals, there's another one right here. The difference is there's a vertical toggle. So if I plug this in here, you can see that on this facade now I have vertical louvers. I can increase them like so. I can increase their depth like so. And then run that again and again and again and again to see where I get, the result that I want. Just keep in mind, like nothing other than that box is modeled inside of Rhino. So the idea is that when your building is still in like a primitive volume, you can run these tests pretty quickly. So, any questions? Does anybody even think they're going to use this? No? Okay, we'll see.
Maybe one day.
Yeah, no, I'm definitely going to make it an assignment. Make sure you have to use it. I don't have control over your class, but I'm sure I can convince Matt. I'm just going to stop recording for a second. I don't think anymore.